Greetings, this is M Squared, and today we're going to talk about relations. We're going to determine whether they're functions, and if they are a function, we're going to figure out if they're one-to-one, onto, both, or neither. Remember, the definition of a function is a relation. Remember, a relation is a set of ordered pairs. So the definition of a function is a relation where every x, each and every x, has exactly one y. So first we determine if it's a function. To do that, if it's in a table or chart, we're going to look at all the x's. And if all the x's are different, then it's a function. So this is a function. Once it's a function, we have to decide whether it's a one-to-one function or an onto function. So to figure out if it's a one-to-one function, we look at the y's. And if we see the y's, and there are any two that are the same, then it cannot be onto. So it's one-to-one. So it's not a one-to-one function because there's two y's that are the same. So next, let's see if it's onto. To be an onto function, each y has to have an x. Well, you see only 4 y's listed, and each one of them has an x. So it is an onto function. And that's that one. Because obviously if it's not B, it can't be C or D. So we know this is a function and it's an onto function. So let's look over here. To find out if it's a function, we look at the x's. They're all different. We're good. It's a function. To find out if it's one-to-one, we look at the y's. They're all different. It's one-to-one. Now, to see if it's an onto function, we look to see, does every y have an x? Yeah, every y has an x. So that means we're dealing with both here. Now, if I had made another little chart here and I put a number here and I didn't put one over here, then it wouldn't be onto, because every y has to have an x for onto, just so you know what that might look like. Now on to graphs. When you have a graph, to determine if it's a function, you use the vertical line test. So we draw vertical lines, and if it only crosses once, then we know it's a function. And this is a function. It only crosses once, so we know it's a function. To determine if it's one-to-one, we do a horizontal line test. So when I do a horizontal line test, again, no matter where I draw the horizontal line on this graph, it only crosses once. So I'm going to put an A there for one-to-one. Now, these arrows mean it goes on forever. Sometimes in the book they don't have the arrows, but you can see it on the graph, and it kind of extends the whole graph, which means that they really do go on. Usually if it doesn't, they'll have like circles, closed circles, or open circles where it stops. So keep that in mind because it's important for the onto function. So for an onto function, I have to make sure that every single y has an x. And since there's an arrow going down and an arrow going up, I know that no matter where on this graph I go, I will eventually have a y. If I go clear down here, I might have to go over a little bit, but I'm going to have a y. So this is an onto function, which means it's both. Probably should say both. So it's a function and it's both onto and one-to-one. On this one, it's a graph, so I use my vertical line test. Vertical line test works. These are going out and down forever. So I know it's a function. One-to-one, I use my horizontal line test. Doesn't work. It crosses twice, so I know it's not one-to-one. Onto, well, there's a whole bunch of y's up here that have no x's. So this is not an onto. So this would be neither. Similar to this, because it's it's kind of a similar shape. It's a V and not a U, but vertical line test works. It's a function. Horizontal line test does not work. It's not a one-to-one function. There's a bunch of y's down here that don't have x's, so it's not onto. So it's neither. Now on to equations. Sometimes that can be challenging. That's why it's so important that you know what the pictures of these are. This is just a set of points, but you need to be able to look at this and know that that's a picture of a line. 3x minus 1, it's in slope-intercept form. If I was to graph that, I'd go down 5 because that's my y-intercept, up 3 over 1, and I'd have a line like that, which we know all lines are functions, unless, of course, they're vertical lines. Functions. It's also one-to-one and onto because it goes on forever. So this is both. But you need to know what it looks like. So important. And if you have a graphing calculator or some graphing utility online or on your computer, you could also do that. But This one, absolute value, that's a v. It looks like this shape. So we already know it's a function, but it's neither one-to-one or onto. And here we have a set of points. That's supposed to be a comma. Here we have a set of points, and so we just look at the x's. Are all the x's different? 1, 2, 3, 4. Yes, so we know it's a function. Are all the y's different? Oops, same y. So it's not one-to-one. But does each y have an x? Yes, so it's onto. So that's how to tell what kind of function you're dealing with. Good luck with that. M squared, signing out.